Question 1. Through the lens of WAN optimization, a multinational company headquartered in Frankfurt notices that remote employees accessing a Senate ERM system experience erratic performance, especially during peak business hours. The EO is Becker, has deployed Riverbed steelhead appliances at both ends but finds only a modest performance gain. A deeper investigation reveals that while deduplication is functioning correctly, high latency persists and EC retransmissions are frequent. What should Becker prioritize next to improve performance given the observed symptoms? A. Upgrade the WAN link to higher bandwidth and rely on RIOS compression only. B. Enable application streamlining on all HTTP applications in the CRM system. C. Focus on transport streamlining to reduce the number of TCP round trips and retransmissions. D. Use a third-party firewall to reduce packet collisions on the WAN segment. Answer. Correct answer. C. Focus on transport streamlining to reduce the number of TCP round trips and retransmissions. Explanation. In Riverbed's RIOS architecture, transport streamlining is key to minimizing TCP inefficiencies, especially over high-latency, lossy links, while data streamlining may already optimize redundancy. Persistent retransmissions and latency issues indicate that a TCP handshake and windowing behavior, contributing to degraded performance. Transport streamlining solves this by mitigating ECP chattiness, accelerating slow start, and improving acknowledgement behaviors. Increasing bandwidth A does not reduce latency. Application streamlining B might help with specific apps, but ECP issues are more foundational. Using third-party firewall D does not address TCP round trips directly. This scenario reflects the exam domain of transport streamlining and its functions. Question 2. A critical examination of WAN optimization deployment reveals that a mid-sized logistics company is using in-path deployment for its steelhead appliances. However, due to a network redesign, they are considering out-of-path deployment to gain routing flexibility and simplify failover. Which of the following is a key consideration or limitation when moving from in-path to out-of-path deployment for steelhead appliances? A. Out-of-path deployment disables SSL optimization permanently. B. In-path appliances cannot perform data store synchronization. C. Out-of-path deployments require manual redirection mechanisms or BER. D. In-path deployment can only operate in half-duplex mode. Answer. Correct answer. C. Out-of-path deployments require manual redirection mechanisms, BER. Explanation. Out-of-path deployment, unlike in-path, does not sit directly on the data path and hence requires external mechanisms such as web cache communication, Proto-E, or policy-based routing, PBR, to redirect traffic to the steelhead. This allows greater flexibility but introduces complexity in routing configuration. SSL optimization A is unaffected by path mode. In-path appliances B can fully support data store sync. Half-duplex mode D is unrelated to deployment mode. This relates to the topic of deployment modes and configurations. Question 3. Based on the information, Mr. Alvin, a network administrator for a remote oil field operation, reports that performance gains from his steelhead device are inconsistent. Sometimes deduplication hits are high, and other times negligible. He investigates the CIFS traffic pattern and notes that file versions vary slightly each time users save them. What optimization feature could most effectively address this issue in the given context? A. Transport streamlining to improve TCP handshaking. B. Application streamlining to address protocol-level redundancy. C. Data store rehydration to enforce byte caching. D. TCP segmentation offloading to reduce NIC overhead. Answer. Correct answer. B. Application streamlining to address protocol-level redundancy. Explanation. When slight changes in file versions result in new data blocks, application streamlining becomes essential. For protocols like CIFS, RIOS's application streamlining removes redundant protocol overhead, improves prefetching, and optimizes metadata operations. Transport streamlining A is more about TCP behaviors. Data store rehydration C is valid RIOS feature. TCP segmentation offloading D is NIC level function, not WAN optimization feature. This question falls under application streamlining and its purpose. Question 4. The core principles of TCP/IP suggest that session setup, congestion control, and retransmission mechanisms introduce latency when operating across high-latency networks. Which of the following describes how Riverbed Steelhead optimized TCP behavior to reduce this latency? A. By increasing the TTL value of IP packets to reduce hop count. B. By modifying TCP window size and suppressing unnecessary retransmissions. C. By encrypting ECP headers for secure transmission. D. By changing ECP to IP to bypass handshake requirements. Answer. Correct answer. B. By modify ECP window size and suppressing unnecessary retransmissions. Explanation. Steelhead's transport streamlining manipulates TCP behaviors, such as expanding window sizes at coalescing and retransmission suppression to minimize TCP-related delays over WANs. TTL manipulation doesn't affect latency in this context. Encryption C is for security, not performance. Replacing ECP with D would break protocol integrity. This question relates to TCP fundamentals and transport streamlining. Question 5. In contrast to simple WAN acceleration tools, Riverbed's RIOS provides layered optimization functions. Company has performance monitoring system that suddenly starts showing low WAN optimization ratios after software update in their HR application. The data payload size remains constant. What is the most probable cause for this drop in optimization effectiveness? A. Increased network latency affecting steelhead compression. B. The updated application now uses encrypted payloads incompatible with deduplication. C. Riverbed appliances do not support optimization for HR applications. D. GUI misconfiguration on Steel Central Controller. Answer. Correct answer. B. The updated application now uses encrypted payloads incompatible with deduplication. Explanation. If applications start encrypting traffic, especially with SALS, Steelhead cannot apply deduplication or compression unless SSL optimization is configured. This reduces optimization ratios significantly. Latency A does not directly affect deduplication. Statement C is incorrect. Optimization is protocol agnostic. GUI misconfiguration D would not affect data plane optimization. This question examines concepts from data deduplication and compression and SSL optimization. Question 6. Given the circumstances, Layla is trying to optimize a branch site where the Steelhead appliance regularly restarts during high traffic loads. Upon checking, the appliance's interface utilization reaches 95% consistently. Which action would most effectively address this problem? A. Enable cost rules to limit business-critical application throughput. B. Schedule reboot during low traffic hours to prevent overload. C. Upgrade to a Steelhead model with higher throughput capacity. D. Reduce NTU size to limit data bursts. Answer. Correct answer. C. Upgrade to a Steelhead model with higher throughput capacity. Explanation. When an appliance reaches or exceeds its rated throughput, performance degradation or restarts may occur. The proper remediation is to upgrade to a higher capacity Steelhead model as defined in Riverbed's appliance sizing guidelines. COS-A limits traffic that may impact users. Scheduled reboots. B. Do not resolve the root cause. MTU changes. D. Affect fragmentation but not core capacity. This refers to Steelhead appliance models and sizing and monitoring and maintaining Steelhead appliances. Question 7. When faced with asymmetric routing issues, network teams often struggle to achieve bidirectional optimization between Steelheads. Which of the following is a viable approach to ensure symmetric traffic flows for proper optimization in such a case? A. Replace all Layer 3 devices with Layer 2 switches. B. Configure to route both directions through the same Steelhead pair. C. Disable RIOS optimization entirely to maintain routing integrity. D. Enable NAT on the Steelhead to route traffic automatically. Answer. Correct answer. B. Configure to route both directions through the same Steelhead pair. Explanation. Asymmetric routing disrupts the bidirectional visibility required by Steelhead for full optimization. ERP or policy-based routing (PBR) ensures that both directions of C are passed through the same appliances, which is essential for establishing TCP state and optimization. Layer 2 replacement A is impractical. Disabling RIOS C removes optimization. NAT-D is not used for routing symmetry. This falls under identifying and resolving asymmetric routing issues. Question 8. While examining the RIOS architecture, a student preparing for the 101.01 exam asks why data streamlining often leads to dramatically reduced bandwidth usage on repeated file transfers. Which principle underlies this RIOS feature's effectiveness? A. Compression algorithms that depend on packet order. B. Byte-level data deduplication that matches previously seen data patterns. C. Dynamic DNS routing to avoid congested paths. D. Protocol replacement for increased throughput. Answer. Correct answer. B. Byte-level data deduplication that matches previously seen data patterns. Explanation. Data streamlining uses byte-level deduplication to detect and replace repeated data with references, significantly cutting bandwidth usage on repetitive transfers. Compression. A. Does reduce size, but not redundantly transmitted data. DNS routing. C. And protocol replacement. D. Are irrelevant here. This question relates to streamlining DSR and its role. Question 9. In the context of Riverbed's GUI and CLI interfaces, which best describes the operational benefit of using CLI for appliance configuration in large enterprise environments? A. CLI enables batch configurations and scripting for faster deployment. B. GUI is the only method for firmware upgrades. C. CLI prevents unauthorized access by default. D. GUI is deprecated in newer Steelhead models. Answer. Correct answer A. CLI enables batch configurations and scripting for faster deployment. Explanation. Riverbed's CLI interface supports automation, scripting, and batch operations, which is critical for scalable deployments and consistent configuration management. GUI B also supports upgrades. CLI C does not inherently provide stronger security and less hardened. GUI D is not deprecated. This is tied to management and interface of GUI and CLI. Question 10. By evaluating various optimization failures, an engineer discovers that their Riverbed deployment is not accelerating HEE's traffic even though licenses are correctly installed. What is the most probable reason for this issue? A. SSL certificates are not imported into the Steelhead for the targeted applications. B. The LAN port is incorrectly connected to the WAN router. C. The compression engine is in bypass mode. D. RIOS cannot optimize layer 4 traffic. Answer. Correct answer. SSL certificates are not imported into the Steelhead for the targeted applications. Explanation. To optimize HEE traffic, the Steelhead must intercept and decrypt SALS sessions, which requires the server's private keys or deployment of SSL peering and certificates. Misconfigured ports B and compression settings C would affect all traffic. RIOS does support layer 4, but SSL is layer 7 protocol. This is based on understanding and configuring secure connections like SSL optimization. Question 11. With the advent of hybrid networks using SD-WAN overlays, Istakar deployed Riverbed Steelhead appliances across multiple sites. However, he observed that performance degraded for cloud-hosted applications even though traffic for these applications was expected to benefit from optimization. After investigating the flow path, he discovered the traffic bypasses the data center and goes directly to the cloud. What is the best way to optimize such traffic using Riverbed technologies? A. Deploy SteelFusion to connect all data center segments to the cloud. B. Apply TCP segmentation offloading of branch steelheads. C. Utilize SARS optimization via cloud steelhead or service chaining with SD-WAN. D. Convert the cloud traffic into SIFS traffic for deduplication. Answer. Correct answer. C. Utilize SARS optimization via cloud steelhead or service chaining with SD-WAN. Explanation. For cloud-based or source traffic, cloud steelhead or integration with SD-WAN via service chaining ensures optimization policies are applied even when traffic doesn't go through the data center. SteelFusion A is for branch storage. TCP offloading. B does not optimize WAN traffic. SIFS conversion. D is technically impossible. This relates to integration with other network devices and cloud source optimization strategies. Question 12. Taking into account that WAN latency is primarily caused by propagation delay and TCP windowing limitations, an enterprise intends to improve throughput for long-distance file transfers. Which optimization technique is best aligned with this goal? A. Data deduplication to reduce redundant bytes. B. Application streamlining to remove protocol overhead. C. Transport streamlining to mitigate TCP inefficiencies. D. Compression to lower packet size. Answer. Correct answer. C. Transport streamlining to mitigate TCP inefficiencies. Explanation. Transport streamlining addresses TCP's natural limitations in high latency environments by adjusting the window size, congestion control, and acknowledgement behavior. This improves throughput without needing app layer changes. Deduplication A and compression D are effective but do not solve round-trip time issues. Application streamlining B helps with specific protocols but not transport behaviors. This is from the topic Transport Streamlining and its functions. Question 13. The growing trend in modernization pushes organizations to leverage Steelhead's visibility tools for performance analysis. Is Fatima, senior network analyst, wants to understand why certain business-critical apps are underperforming even though deduplication is active. Which Riverbed tool or interface will provide the most granular insight into application layer behavior for her investigation? A. Steelhead Client Interface Diagnostics. B. Steel Central App Response integrated with Steelhead. C. Windows Performance Monitor with Rios plugin. D. SMP mid counters for WAN port. Answer. Correct answer. B. Steel Central App Response integrated with Steelhead. Explanation. Steel Central App Response offers deep packet inspection and performance metrics at the application layer, allowing insight into transaction time, app delays, and protocol behavior. Eclair offers limited diagnostics. Windows Performance Monitor C is not natively integrated with RIS. SMP counters D provide interface stats, not application-level detail. This relates to using Riverbed tools for network visibility and analysis. Question 14. While it is true that cost can prioritize traffic, a company experiences degraded VoIP quality even after enabling costs on the Steelhead appliance. Mr. Bradley, the network engineer, confirms that prioritization settings for RTP are correct. What should Mr. Bradley verify next to improve VoIP performance? A. Deduplication settings for SIP packets. B. Whether WAN bandwidth has been correctly defined for cost enforcement. C. Whether SSR optimization is active on the Steelhead appliance. D. DNS refetching is enabled for SIP clients. Answer. Correct answer. B. Whether WAN bandwidth has been correctly defined for cost enforcement. Explanation. For cost to function, Rios must have accurate WAN bandwidth values to apply queuing and prioritization. Without correct settings, cost policy mapping fails or is misapplied. Deduplication A has limited value for real-time traffic. SSL-C is irrelevant to VoIP. DNS-D does not affect cost classification. This belongs to traffic shaping and quality of service costs. Question 15. In response to frequent complaints about performance degradation, June runs a performance report from her Steelhead management console. She notices that a large portion of traffic marked as pass-through belongs to custom ERP software. What could be the most likely reason for the lack of optimization for this application? A. Steelhead only optimizes web traffic HEs by default. B. The ERP application uses an unsupported or encrypted protocol not recognized by Rios. C. Pass-through traffic indicates an optimization policy mismatch but still accelerates performance. D. Custom applications must be recompiled to be compatible with Steelhead. Answer. Correct answer. B. The ERP application uses an unsupported or encrypted protocol not recognized by Rios. Explanation. Pass-through traffic is often a result of unencrypted or unsupported protocols preventing Steelhead from applying optimization. For optimization, Rios must identify and pass protocol headers. If a custom app uses proprietary encryption, optimization won't apply unless SSL configuration is adjusted. Option A is incorrect. Steelhead supports more HE. C misinterprets pass-through behavior. D is false. Applications don't need recompilation. This is from diagnosing and resolving optimization failures. Question 16. The impact of improper appliance placement can severely limit optimization. Mr. Omar installed Steelhead devices only at branch sites, believing WAN traffic would still be accelerated to the central file server. Which underlying principle did Mr. Omar fail to apply correctly? A. Rios only functions in hub-and-spoke network topologies. B. Optimization requires steelhead devices on both ends of the traffic flow path. Only TCP traffic can be optimized by a single steelhead. D. Data deduplication requires FELS routing tables. Answer. Correct answer. B. Optimization requires steelhead devices on both ends of the traffic flow path. Explanation. To achieve full optimization, steelheads must exist at both ends of the flow, enabling symmetric visibility and processing, e.g. handshake manipulation, streamlining. One-sided deployments only allow limited benefits. Hub-spoke topologies are not a requirement. TCP null optimization C is false. MPLS D is unrelated to the duplication. This ties to sizing and placement of steelhead appliances. Question 17. To better understand how Rios handles SSL traffic, consider a case where a global firm needs to optimize traffic from its Salesforce sales application. SSL inspection is prohibited due to privacy rules, but they still want performance gains. Which Riverbed feature enables optimization without decrypting SSL payloads? SSL client-side caching. B. Path selection based URL classification. C. Metadata optimization through ATPS header analysis. D. SSL proxy tunneling without full handshake termination. Answer. Correct answer. D. SSL proxy tunneling without full handshake termination. Explanation. When SSL decryption is disallowed, Riverbed offers SSL proxy tunneling, allowing the appliance to track sessions and apply limited optimization, e.g. routing, caching decisions without decrypting payloads. Options A and C are not standard Riverbed terms. Path selection, B, helps traffic direction, not optimization. This is under understanding and configuring secure connections like SSL optimization. Question 18. The prevailing attitude toward compression is that it's sufficient to reduce WAN traffic. However, firm using Rios finds that enabling compression alone offers minimal gains for image and video transfers. What explains the limited improvement in this case? A. Rios compression is incompatible with media file types. B. Compression algorithms are most effective on highly redundant data. C. Steelhead appliances cannot process non-EP data. D. Media optimization must be manually enabled in the GUI. Answer. Correct answer. B. Compression algorithms are most effective on highly redundant data. Explanation. Compression works best on redundant text-based data. Pre-compressed files like JPEG, MP, or ZIP provide minimal gain because their entropy is already reduced. Rios can process such files, but efficiency is limited. A is incorrect. C is misleading. Steelheads support TCP primarily, but not exclusive. D is false. No media-specific toggle is required. This relates to data deduplication and compression. Question 19. Among the various Riverbed products, which provides the best integration of WAN optimization with storage consolidation and virtualization for branch offices? A. Steel Connect. B. Steel Central. C. Steel Fusion. D. Steel Flow. Answer. Correct answer. C. Steel Fusion. Explanation. Steel Fusion integrates WAN optimization, edge virtualization, and storage consolidation, allowing branches to operate without local data storage. It's purpose-built for distributed enterprises. Steel Connector is SO-WAN focused. Steel Central, B, is for visibility and monitoring. Steel Flow, D, is component used for telemetry. This question references Riverbed product portfolio, their function. Question 20. To illustrate this point, Lin is attempting to troubleshoot port optimization for a branch file server. After initial checks, he finds that traffic is correctly classified and symmetric, but optimization ratios remain below expectations. What should he examine next to identify potential causes? A. Verify that Rios version supports jumbo frames. B. Ensure that all steelheads have synchronized data stores. C. Increase TCP window scaling on the LAN switch. D. Reboot the steelhead every 24 hours. Answer. Correct answer. B. Ensure that all steelheads have synchronized data stores. Explanation. If data stores are out of sync, the steelhead won't find matches for byte-level deduplication, causing low optimization even on symmetric and recognized traffic. Rios version A is less relevant unless frame size is explicitly affecting flow. TCP window scaling C is helpful but not the root cause. Regular reboots D are unnecessary. IST monitoring and maintaining steelhead appliances and analyzing and interpreting performance reports. Question 21. In a modern context of enterprise WAN optimization, ISTA D'Souza is reviewing performance reports for global financial firm. He observes that remote branches consistently get lower throughput for large SAP transactions despite steady optimization ratios. He also discovers SAP servers were recently migrated to public cloud. Which of the following is most likely affecting WAN performance in this scenario? A. Steelhead appliances don't support optimization of transactions larger than 50 megabytes. B. Application streamlining is not supported in public cloud environments. C. Cloud traffic may bypass optimization paths without proper redirection mechanisms like SARS optimization. D. SAP transactions over GTP are not deduplicated by RIOS. Answer. Correct answer. C. Cloud traffic may bypass optimization paths without proper redirection mechanisms like SARS optimization. Explanation. When enterprise apps move to the cloud, traffic might avoid steelhead optimization paths. Without cloud steelhead or SARS redirection, via pack optimization is bypassed. RIOS support HTTP-based SAP traffic, and there is no 50 megabytes cap. Application streamlining works in the cloud when correctly deployed. This involves deployment modes and configurations and SARS traffic handling. Question 22. To what extent does RIOS handle optimization in environments with frequent TCP session resets due to firewall timeouts or asymmetric routing? Which feature allows Riverbed appliances to maintain optimization even if only one side of the TCP session is visible? A. PAT selection failover mode. B. Full proxy termination with keep-live emulation. C. Enhanced auto-discovery with pro-based recognition. D. HAFO TCP session optimization with delayed ACK spoofing. Answer. Correct answer. B. Full proxy termination with keep-live emulation. Explanation. RIOS terminates TCP sessions using full proxy mode, allowing the steelhead to simulate TCP behavior to the client server even if one direction is interrupted or asymmetric. This maintains state using keep-lives and ACKs. Path selection A routes traffic. C and D don't reflect actual Riverbed capabilities. This aligns with transport stream and high availability and failover configurations. Question 23. Despite the fact that deduplication is functioning, a new intern notices extremely low optimization rates during his testing of file transfers between sites. The files contain random noise and do not compress or repeat often. Why would Riverbed's optimization be limited in this case? A. RIOS was not rebooted after configuration changes. B. Steelheads do not optimize up traffic. C. Randomized data lacks redundancy, rendering deduplication and compression ineffective. D. The data is encrypted by default over the LAN. Answer. Correct answer. C. Randomized data lacks redundancy, rendering deduplication and compression ineffective. Explanation. Deduplication and compression are only effective on redundant data patterns. Files containing randomized or pre-compressed content, e.g. noise or video, do not offer optimization potential. Encryption over LAN. D doesn't block optimization unless SSL. B. B is not the protocol here. Rebooting A is unnecessary post-optimization config. This relates to data deduplication and compression. Question 24. The traditional approach to configuring optimization policies on Steelhead involves default recognition of common protocols. However, ISTA Navarro introduces a custom messaging protocol for internal applications. Which of the following actions must be taken to optimize this custom protocol effectively? A. Replace the protocol header with ATE using a proxy. B. Define a custom port-based application rule and enable basic optimization features. C. Wait for Riverbed to provide a native optimization module. D. Enable upflow feature to auto-detect protocol patterns. Answer. Correct answer. B. Define a custom port-based application rule and enable basic optimization features. Explanation. Custom applications can be optimized by defining port-based application classes and enabling basic optimization policies like compression and deduplication. RIOS won't perform deep protocol-level optimization unless specifically supported. A is risky and unnecessary. C is time-consuming and not practical. AppFlow D isn't Rio's feature. This concerns configuring and managing optimization policies. Question 25. Focusing specifically on traffic shaping and network quality, an ISP introduces frequent jitter and delay in video conferencing streams between company locations. Steelhead appliances are in place, but video quality remains inconsistent. Which Riverbed feature is most suitable to enforce stable video quality under fluctuating network conditions? A. TCP window scaling with aggressive ACK delay. B. Cost classification and prioritization for real-time traffic. C. Encryption offloading for faster processing. D. File prefetching using application streamlining. Answer. Correct answer. B. Cost classification and prioritization for real-time traffic. Explanation. To ensure video conferencing maintains quality, cost policies must classify real-time traffic like REP and prioritize it over the WAN using diffserv or similar mechanisms. ACK delay A affects TCP, not TTP, encryption offload. C helps SSL apps. Prefetching D is for file-based traffic, not streams. This aligns with traffic shaping and quality of service costs. Question 26. From multiple perspectives, Steelhead appliances use transport layer optimization for TCP. However, what specific mechanism allows Rios to accelerate TCP slow start behavior in long-distance connections? A. Multiplexing LAN and WAN flows at layer 2. B. Suppressing SYN retransmissions at the branch. C. Decoupling ECP handshakes between client and server via proxy. D. Upgrading NIC firmware to optimize initial segment delivery. Answer. Correct answer. C. Decoupling TCP handshakes between client and server via proxy. Explanation. Rios accelerates TCP slow start by decoupling TCP sessions, handling handshakes locally on both sides and accelerating window growth. This speeds up transfers across long distances. Multiplexing A is not a Rios function. SYN suppression B is not safe. NIC firmware D does not relate to TCP behavior. This transport streamlining and its functions. Question 27. Examining the consequences of appliance misconfiguration, the security audit finds that Steelhead optimization was bypassed for several sensitive applications, though policies existed. This Riley suspects SSL is the root cause. Which setting most directly affects whether SSL traffic is optimized? A. Enabling duplex mode on the WAN interface. B. Installing server-side certificates into Steelhead's SSL configuration. C. Reducing MS on the WAN to match MTU. D. Enabling NetFlow on the Steel Central controller. Answer. Correct answer. B. Installing server-side certificates into Steelhead's SSL configuration. Explanation. To optimize SSL traffic, Rios must decrypt and re-encrypt the stream. This requires access to server private keys or digital certificates on the Steelhead. Without these, SSL traffic is passed through unoptimized. Duplex settings A, SSC, and NetFlow D do not contain SSL optimization. This relates to understanding, configuring secure connections like SSL optimization. Question 20. The effectiveness of WAN optimization can be validated through reporting. Mr. Gomez uses the Steelhead Management Console to analyze performance metrics. Which of the following metrics most accurately reflects the bandwidth saved by optimization? A. Latency reduction score. B. TCP retransmission index. C. WAN capacity gain. D. Peak compression factor. Answer. Correct answer. C. WAN capacity gain. Explanation. WAN capacity gain reflects how much additional bandwidth is effectively added through optimization techniques, including deduplication, compression, and streamlining. Latency scores A and retransmissions. B. Relate to quality, not savings. P. Compression factor. D. Only reflects compression, not all optimization. This is covered in analyzing and interpreting performance reports. Question 29. The development of Rios enables protocol-specific acceleration. However, a common misconception is that all traffic will benefit equally. Which protocol below typically sees the greatest performance gain from Riverbed's application streamlining? A. ENS. B. SIFM. C. IMP. SFP. Answer. Correct answer. B. SIFM. Explanation. CIS benefits significantly from application streamlining because it's chatty with multiple round trips per file operation. RIOS reduces latency and improves throughput via metadata prediction. Read ahead and write behind. DNS, IPC, and SMPD are low bandwidth protocols not deeply optimized. This relates to application streamlining and its purpose. Question 30. The question remains whether Steelhead appliances can adapt to failover situations. ISTA-sync tests. A branch Steelhead connected to two routers. Upon failure of the primary router, WAN optimization ceases even though connectivity resumes through the second path. What should ISTA-sync configure to maintain optimization during failover? A. Enable multi-path optimization with auto-discovery protocol. B. Configure high availability with path redundancy in RIOS. C. Use compression-only mode across all interfaces. D. Disable optimization until routers converge. Answer. Correct answer. B. Configure high availability with path redundancy in RIOS. Explanation. For optimization to continue after WAN failover, high availability settings must be configured properly, including failover paths, redundant routing, and interface tracking. Without this, optimization breaks on path changes. A is not a standard feature. Compression only C limits optimization. Disabling optimization D defeats the purpose. This refers to high availability and failover configurations.